So yesterday we completed this robot drawing. And I just wanted to review with you what a scale drawing is. Alright, so when we have a scale drawing, it's a reduction or enlargement of an original drawing or photo. Okay, so now we're actually going to get into the math part of this. What we're going to see is that included in scale drawings are actually proportional relationships. Alright, so let's get into that. So if you go down on lesson 16, we'll go through example 3. So it says Celeste drew an outline of a building for a diagram she was making, and then she drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. Well, before we get into that, if A is our original and B is the next picture or the scale drawing, we could call B a reduction, right? So we reduced our original picture. Okay, so let's see. State the coordinates of the vertices and fill in the table. So on A, we know that this point up here has coordinate pairs of 5, 6, 7, and 15, 16, 17, 18. And this one is 13 and 18. Okay, so that would mean then, on the original drawing, that the height of the rectangle would be 18 units. Units just being the squares. And the length then is, let's see, let's count how many squares. 1, 2, 3, 4, 5, 6. Okay, and so now let's look at our second drawing. Our coordinates are 5, 6, 7, and 9, and we have 10 and 9. Right, so let's fill in our table. The height of our second rectangle is 9, and our length is 3. Now, you should be able to look at this table and say, hey, I think I can make some ratios from here. So if I'm going to take, let's say I give the height the variable h and the length the variable L, I should be able to look at a ratio that is h to L. Alright, let's see what happens when we replace those variables with numbers. Alright, so we have 18 to 6. And we also have 9 to 3. What's interesting about that is that these are equivalent ratios. So if we have equivalent ratios, then we know that we have a proportional relationship. Proportional relationship. Because we've been using equivalent ratios to find our missing pieces of information. Okay, so let's explore that a little bit more. We're going to explore that a little bit more. Alright, so we have our next person. His name is Luca. Luca drew and cut out small right triangle for a mosaic piece he was creating for art class. So let's look at the height of the original image. So let's say that A is original and B is the second image. And we would want to say that B is an enlargement. Let's see what happens. So the height of our original image is 1, 2, 3, 4, 5. And the width, you should see that it's 3. Okay. The height of the second image is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the base is 5 to 15, which is 10. Alright, so let's take a look at that. So it says to fill in the table. Does a constant proportionality exist? So can I multiply my height by a certain value to get width? Is there a k value? What do you think? Well, let's find out. I need to take my 3, right? 5 times k is equal to 3. Alright, and my k value would end up being 3 over 5. Do we get 3 over 5 for the other one? Let's see. 15 times k is equal to 10. K value is equal to 10 over 15. Alright, our k values don't match. Okay, so non-proportional relationship. Okay, so now we go to, is Lucas' enlarged mosaic a scale drawing of the first image? Why? Explain why or why not. Since they don't have a proportional relationship, we can't say that they're scale drawings. So we'll say no, because no proportional relationship exists between the sides. Okay, meaning that the height and the width are not related the same way for both images. Alright, so that's what that means. Okay, so for homework you were supposed to do the problem sets with the images, so let's do that now. So the scale drawing would be an enlargement. And then this would be a reduction, because it's smaller. This one, of course, is an enlargement, because it's larger. Alright, so I want you to try doing 4 and 5 on your own. And compare with a neighbor if you can. Alright, have fun.